Is my screen visible? Cool. Thanks, Ian. Okay, it's time. Welcome everyone to the distribution team training. So this session is about Let's Encrypt integration in omnibus-gitlab. So yeah, for anyone who is watching the recording, my name is Balashankar. I am a software engineer at the distribution team here at GitLab. So in this session, I'll be covering topics like uh, how we actually developed the whole integration, what was the development timeline, where we started and what we ended up with, and some of the technical difficulties that we faced during this development. And I'll give a general idea about how Let's Encrypt works and how we integrated it to omnibus-gitlab. Then we'll walk through what actually happens during a reconfigure when someone runs GitLab control reconfigure. Then we'll see a bit about what are the actual components that we are using for this integration. And obviously there are some gotchas or some issues and future modifications that we need to do. So I'll take a glance at that too. So to begin with, we started Let's Encrypt integration work for GitLab 10.5, and we reached a mature stage by GitLab 11.0. So you can see the linked MRs in the slides. So these are the main modifications that we made for this integration. First of all, let me go through some of the few technical difficulties that we faced in this integration that came from Let's Encrypt itself. So the first and most important one was the rate limits that Let's Encrypt had in place to prevent abuse. So the one that was so focused was the rate limit for failed validations. So Let's Encrypt has this 5 limit, like 5 failed validations you can have per account, per hostname, per hour. So if we try more than 5 times and you get your validation fail, you cannot try it again for another hour. So this was one of the problematic difficulties that we faced. So the next one was more regarding the options that we could use, the features that Let's Encrypt provided. So Let's Encrypt recently brought something called wildcard certificates that supports all the subdomains of a specific domain. However, this was only available via DNS verification. So it expects the users to go to their DNS management, set a specific record there so that Let's Encrypt can verify whether the domain is actually owned by the specified user or not. So this required quite a lot of manual intervention from the user. They need to figure out where their DNS manager is. They need to add these records, wait for the DNS to actually propagate to everyone, and then hope that Let's Encrypt can actually resolve that. And another difficulty or another option that Let's Encrypt provided in the past was something called TLS SNA authorization. So this was also used to authorize a user that to confirm that the user is actually the owner of a specific domain. So because of some vulnerabilities discovered, they dropped the support for this method while we were working on this integration. So mid development, we had to switch to the HTTP authorization that we currently use, about which I will talk later. So these were some of the technical difficulties that we encountered, and we found ways around to integrate Let's Encrypt to omnibus-gitlab. So to give you a general idea about what this integration means and how it is useful to users. So as a one-liner, this integration automatically generates SSL certificates for the GitLab instance that a user has without the user actually doing anything. They just need to specify a URL, and omnibus-gitlab will do everything for them. Get a certificate, put it in place, make Nginx look at that position and have everything worked out. So it currently supports the GitLab domain, registry domain, and the Mattermost domain. So users can specify https gitlab.example.com or registry.example.com, and they can forget about everything. Omnibus-gitlab will do everything. So this is gated by an attribute in the gitlab.rb file that users use to configure everything about GitLab. So we actually have coded a heuristic to detect whether user actually needs us to provide a certificate or whether they are providing their own certificate. So this gating is automatically set to true if the user has HTTPS specified and user hasn't provided any of their own certificates. So our integration, as I mentioned earlier, uses HTTP authentication for validating. So Let's Encrypt actually visits the domain and makes sure, okay, this domain actually owns to this user because it satisfies all these criteria. So to go a bit technical, how the certificate looks like or how the internals work is that the actual GitLab domain is the common name of the certificate, and other services, whether it be registry or Mattermost, they are added as subject to the names assigned to this certificate. So this basically means the certificate is issued for the GitLab domain, and all the other domains are added as alternative fields, so they apply to these other services also. And one other feature of this integration is the reconfigure. Whenever a user runs reconfigure, it automatically checks whether the certificates are expiring soon. If they are, it will automatically renew without the user need to do anything. And we also have an configuration or an option to configure a cron-like service that will automatically do without waiting for a reconfigure. So in short, users just need to set their URLs, and we will control everything from getting the certificates, automatically renewing them, and making sure all the connections to GitLab are encrypted, like SSL encrypted. So this was the general idea. So we actually make use of 3 open source libraries or projects for this. One is the Chef Acme cookbook that actually does most of the heavy lifting interacting with Let's Encrypt. It uses a Ruby gem or Ruby library called Acme client that actually performs the requests and responses from Let's Encrypt server. And for automatic renewal, we use a Go library called Go crondy that provides a cron-like functionality. So we'll look into the details of how we use these libraries in the coming slides. So I talked about us developing a heuristic to automatically detect whether users expect an SSL certificate or whether we should automatically create an HTTPS certificate. So this slide actually shows how we come to that conclusion, how we make that decision. So to cite from the slide, so we check whether the protocol is HTTPS. If the user has specified HTTPS in their external URL, in their registry domain, or in their methodmost domain. Next, we check whether user is using our Nginx or whether they are providing their own. So we can only work with our own Nginx. So we confirm Nginx is enabled. And then we confirm Nginx is actually listening to HTTPS, whether request coming to port 443 is handled by HTTPS. And last, we need to make sure the user hasn't provided any certificates of their own. So the certificates need to come from us. So we use a special configuration called auto-enable to differentiate between certificates that the user provider and the ones we generated. So this is in place to handle future reconfigurations, whether the certificates found in specific location was provided by the user or was generated in a previous run of reconfigure. So this field actually helps us separate between the two and makes this heuristics understand in make it work in the future runs of reconfigure. So this is the basic key component of the whole integration. It decides whether we need to invoke the whole recipe, we need to ask let's encrypt, or we need to do anything. So this is the key component of the entire integration. So now let's take a look at what actually happens when user runs a reconfigure. So user has set their URLs in their GitLab.rb file. They have set their external URL, the registry or Mattermost, whatever stuff they have, they are ready to run reconfigure. So while running reconfigure, we initially apply the heuristics that we saw in the earlier slide to detect, okay, whether we need to do something or is user prepared with their own certificates. So the entire integration works only if that heuristics return a true value, like we need to enable let's encrypt. So the first thing we check is whether any other services are configured, and whether they are configured with HTTPS, and whether the heuristics apply to them also. So if registry or Mattermost is specified with HTTPS and the user hasn't provided a certificate, we add them to the list that we request let's encrypt for a certificate for. So that's the first step. The next one is we need to update Nginx configuration. So this is to make sure that as part of this authorization, when we request a certificate to the let's encrypt server will actually try accessing this domain that we specified and checks whether a specific file is in place. So this is to make sure that we actually control the domain, we can place files in place, and we can make sure the files have necessary content. So this is called HTTP authorization. It makes sure that the user who requested a certificate is the actual owner of the domain. So for that to happen, the Nginx needs to be told, okay, when a request comes to this specific location, point it to this specific file. So we update the Nginx configuration if we detect let's encrypt needs to be done. So we redirect all the HTTP traffic to HTTPS so that all the communication with GitLab server from a user will be encrypted. We specify the SSL certificate and certificate key for Nginx. So Nginx knows where to look for the certificate and key. Then we add a location directory for this well-known file. So well-known file is something let's encrypt asks the users to create at a specific location to confirm domain ownership. So we add a specific configuration to Nginx to tell it, okay, if a request comes for well-known file, go look at this folder. So we modify the Nginx configuration like this. So one of the problems in this scenario is we have already set an SSL certificate and certificate key. So Nginx will not start functioning without actually finding these files at that location. So because we don't have any certificate or key yet, Nginx will fail to start. To work around that, we actually create temporary self-signed certificates and put it in these places so that engineers can start and start processing requests. So we create two temporary certificates and key, and we put it in the places mentioned in Nginx configuration. It will be overwritten when we actually get the original certificates. So once that is done, we use the components that I mentioned earlier. We use the chef as cookbook. So that actually has a resource, a chef resource for requesting certificates from Let's Encrypt. So in the beginning, I mentioned about one of the technical difficulties with Let's Encrypt, that was rate limiting. So we cannot go on requesting over and over if something fails, and we will hit the rate limit, so we cannot request it again. So to make sure all our requests go through and our domain can be verified without any problem from Let's Encrypt side, we split this process to two stages. In the first stage, we request certificates from the staging endpoint of Let's Encrypt. So Let's Encrypt provided this staging endpoint just for this purpose. It is much more relaxed about rate limits. You can make much more requests and failures without getting blocked from doing it for another hour. So first we request a certificate from the staging endpoint. So if we get an actual certificate, it means the authorization has completed. So the authorization can work without issues. Let's Encrypt can access our domain without any problems and find the well-known file that we placed in that position without any issues. And it is safe to request the actual certificate. So once we get a certificate from the staging endpoint, we move forward and request the actual certificate. And once we get those certificates, we put it in the places that we mentioned in the Nginx configuration. So then we reload Nginx for all these changes to take effect, so that Nginx can start using the certificates for all the communication. And one last thing we do is, in future reconfigures, we need it to check, okay, whether the certificate is nearing expiry, whether it can be renewed or not. So for that, we need this whole process to be done. So we need Let's Encrypt recipe to be run. So here is where the auto-enabled option that I mentioned in the heuristics comes into play. We set auto-enabled true, pointing future reconfigures that the certificate that is present in the location was generated by Let's Encrypt by this integration. It is not something the user provided, it is something that we generated. So we have to check for expiry, we have to do automatic renewal. So we mark this in the auto-enabled option. Because this needs persistence, we write it to the disk as part of the secrets file, where we store all the persistent data that is needed for reconfigures. So till this, starting from detecting whether user has specified HTTPS, till writing the auto-enabled features to the persistent disk. So this completes all that a user would have to manually do to get a certificate from Let's Encrypt. We automated every step in that process via this chef recipe, via this reconfigure process. So at last, if user has opted for an automatic renewal, we add a cron job to run this thing over and over again. So in case user don't want to wait for reconfigure or don't want to run a cron job, we provide a one-line command called for renew, just checking for expiry and renewing the certificate. So either user can manually run that command themselves, so they can set a cron job themselves, or they can use the options we provide to set a cron job. So if they use the option, we add a cron job running this renewal command. So this happens in the entire reconfigure. Does anyone have any doubts or questions at this point? Okay, good. So moving on, we take a look at the components. We mentioned three components. The first one is Chef Acme Cookbook. So this is a chef cookbook that basically does all the heavy lifting that we perform in this integration. It provides two resources. One is to generate a self-trained certificate, which we use to temporarily put in place so engineers can come up. Then it provides a resource for the actual lesson certificate. It uses the Ruby gem called Acme client to make a request to lesson grid, get the response back, decipher what the response is, and get the certificate and everything. So this cookbook implements automatic renewal. It is based on few conditions like whether the certificate in place expires within 30 days, whether any of the names associated with the certificate, like the URLs associated with the certificate have been modified. So if any of this is true, it will get a new certificate or it will renew the certificate. So this basically does all the internal processing of this integration. We just wraps around this cookbook and provides necessary hooks with our reconfigure process. So this is one of the key components of the whole process. The next one is the Go library for automatic renewals. So this is a cron daemon written in Golang. It supports the cron tab syntax that Linux or Unix users are familiar with. It outputs its logs to standard output or standard error 5. So it goes very well with the whole of omnibus-gitlab infrastructure. Like it works well with runage. We can start and stop the service with runage. It can print to the svlog daemon controlled directory. So this works well with the omnibus-gitlab architecture. So this is the architecture of the entire integration and the process that takes place when a user runs reconfigure. So obviously there are some more modifications or some issues that we are yet to fix or some gotchas. The first one is this automatic HTTPS certificate generation cannot work in private networks. So Let's Encrypt server needs to actually visit the domain or access the domain to make sure the ownership is correct and it is actually owned by the user. So the domain needs to be resolvable from global internet. You cannot use it in an internal network with private IPs or internal IPs. The second one is it requires standard ports to be used, like port 80 and port 43 should be used. Like Let's Encrypt should be able to reach the site on port 80. So if you are using some non-standard ports like 484 for HTTP, it will not work. And the third one is it does not support GitLab pages yet. It only supports GitLab registry and Mattermost, not pages. So there's an issue open about that issue 3342 in the omnibus-gitlab issue tracker. And we have few other open issues to say like how to do DNS verification or how to do wildcard certificates so that we need not add all these individual services. But those are still open and we need to implement them or do research and implement them to make it much more easier for users to get HTTPS without any hassle. So yeah, that's it. Questions, anyone? Let me look at chat. Okay. Going 1, 2, 3, 4, 5. Yeah. So thanks everyone for listening. Hope you got some idea of how Let's Encrypt works with omnibus-gitlab packages. So thanks for joining. See you everyone.